Okay, so let's start going through the homework. I know these homework problems are harder than what you were used to before. The pattern continues, which is the idea of preparing you for a difficult college class. If you do a bachelor's of arts degree, hey, you won't have anything as hard as this physics the whole time you're in college. But if you do a bachelor's of science degree, you'll just start out at this level. Okay, so the first one was 136. Caleb, do you have that? Good. Okay, so these are our answers. All you had to do was find the x and y components of the vector, so it really wasn't hard at all. The x is the I, the y is the j. Sometimes they switch the j and the I, but it's still the same thing. The x is the I, the y is the j, and then in D you had to multiply b times 5, where b was 4i. So you multiplied that and you just got 20 minus 60. Okay, the next one, 138. Find the magnitude of each vector, and that's just our Pythagorean theorem, and then a minus b, etc. Jaden, do you have 138?
Okay, I have 6, 90b, 9, and a minus b, negative I plus 9j, and for C, I have 9.06, and the angle measured is 96 degrees.
Good. Everything. What did you say you got for b? Magnitude of b?
Negative 1.00 plus 9j.
I mean this one. I thought I heard you say a different number here. Magnitude of b. It should be 5.39.
5.39.
Okay, good. All right, so we had this a. This is our x. This is our y. We get the magnitude. Use Pythagorean theorem. 8.06. Then we have b. This is our x. This is our y. The x is the I. The y is the j. We do the Pythagorean theorem. We get 5.39. So we're doing the same things over and over. Pythagorean theorem, arctan. Pythagorean theorem, arctan. The next one was 140. Oh, wait. Then we had to finish. Then we had a minus b. So we subtracted the x from the x, the y from the y. Okay, so it was the 4 minus the 5, the 7 minus the negative 2. Okay, so that gave us minus 1 and 9. So our x is minus 1, our y is 9. Then we had to do Pythagorean theorem in arctan again. Okay, so we just get 9.06 and 96.3. Okay, now 140. Kyla?
Okay. 116.6 7.4 C 4I plus 8J and 63.42.
Okay, good. I think you got the complement for B. So A was arctan 6 over negative 3 or negative 2, which gives you 117. B was arctan 2 over 7. I think you did 7 over 2. So we get 15.9. Now you can tell if your x component is bigger than your y, it has to be less than 45 degrees. And then C, we first had to get our components, so we got 6 plus 2 for our y and negative 3 plus 7 for our x. So then we did 8 over 4, arctan 8 over 4, and we got 63.4. Okay. Then we had 142. Find the scalar product of the vectors A and B given in exercise 1.38. You could use either definition. You should just use the easiest one. Find the angle between these two vectors. At the end of class, I went through 2 different techniques for getting your angles. Jaden, do you have this?
I have 6 and negative, or not negative, sorry, 6 and 82.06 degrees.
Good. So we went through the dot product, which is the x times the x, so 4 times 5. The y times the y, 7 times minus 2. So we get 20 minus 14, which is 6. Our dot product is just a number. It has no direction. Now, to get the angle, you could do arctan of the two and get the difference between them, and I went through that at the end of class. Or you can do our cosine of this whole thing, the dot product divided by the magnitude times the magnitude, and I went through that with you. Okay, so either way, you should get 82.1 degrees. So if you got the arctan, you would have subtracted them and gotten 82.1 as their difference. Then we had 145. Find the angle between each of these pairs of vectors. So you had to do the same thing, either do arctan for each one and get the difference, or do the arc cosine and do the whole magnitude of A, magnitude of B, and dot product equation. Kaylee, did you get this?
For A, I think I can 65 degrees. For B, I have 21. And for C, I have 90.
Good. So they're doing the arc cosine thing. They got the dot product between the two, divided by the two magnitudes. So it's just one step, but there's more to it than when you do the arctan. Then the same thing here. This one, the dot product is 0, so we know that angle is 90 degrees. Okay. Now, so all we looked at so far was the multiplication of 2 vectors where we get a scalar. So now we're going to move on to multiplying a vector times a vector and getting a vector. So if the vector product, when you multiply a vector times a vector and get another vector, it's called the vector product. If the vector product of 2 vectors is A crossed with B, then we get this. Okay, so write that down. The magnitude of the vector cross product is the magnitude of A times the magnitude of B times the sine of phi. So instead of doing cosine, we're doing sine. Now, I mentioned before that torque was an example of this. And remember how we use sine for torque. We use cosine for work, we use sine for torque. Now, a vector has both magnitude and direction. So this is called the vector product or cross product. So we have the magnitude of A times the magnitude of B times the sine of phi. Same thing as what's in your book. Now, every vector has direction. So how do we figure out the direction? It's another right-hand rule. Okay, Okay, the direction of the vector can be found using the right-hand rule. You place the two vectors tail to tail. You point the fingers of right hand along A with palm facing B. You curl fingers towards B and the thumb points in the direction of A crossed with B. Okay, so for example, if this is A and this is B, I place A and B tail to tail, point fingers of right hand along A with palm facing B. Curl fingers towards B like this and your thumb points in the direction. So the thumb is out of the board. It's always out from the plane that A and B are in. So my direction of this would be this direction K. If I switch this now and I make this A and this B, okay, so now I point fingers of right hand along A, with palm facing B, curl fingers towards B. Now it's into the board. So it's always going to be out of the plane. So if it were like this, it would be that way. If it's like that, it would be down. So we have to have direction for having, if we have a vector. So our sum is a vector, so we have to have direction. So this is our torque, which was either clockwise or counterclockwise. And remember, something was rotating this way, right? We had a negative torque. Okay, so we would curl our fingers, it would be into the board like that, it would be negative. If it went this way, curl our fingers that way, it would be out of the board, it would be positive torque. It is anti-commutative. Okay, so A crossed with B not equal to B crossed with A, it's the negative. So when we did the dot product, it was commutative. A dot with B was equal to B dot with A. But the vector product is not, because it's going to be in the opposite direction. Okay, so it changes by 180 degrees. Okay, so B crossed with A has the same magnitude as A crossed with B, but points in opposite direction. It's basically 180 degrees apart. So you don't have to go through and do all the math when you do A crossed with B and B crossed with A. You have the same magnitude, but you have opposite directions. So all you need to do is put the same magnitude and change your direction. So if you have 5K, you would have negative 5K. So our answer is no longer a number, right? Our answer is a vector. So you put it in terms of I, J, or K, or all of them. You can have your answer, if I have an XY plane like this, this is my XY plane. What I would have if I'm going this way would be positive K. Going the other way would be negative K. So let's say you got 10, you would put 10K. And if you go the other way, you would put negative 10K. Now, if I have this coming out from the board like this, then I'm going to have an I, J, and a K in my answer. So in your answer, you have a vector. Now, when we did physics 1, we didn't work with I, J, and K, so we didn't use those terms. We just called it clockwise or counterclockwise. But now we're going to put it in terms of vectors like I, J, or K. So if you are working with 2 dimensions, you have only 1 dimension coming out. If you go in with 3 dimensions, you have 3 dimensions coming out. Use A, B, sine, phi to find the magnitude and the right-hand rule to find the direction. Okay, so when we're given it in terms of magnitude and angle, getting the vector cross product is not very hard, just like for the dot product. It's just the magnitude of one times the magnitude of the other times the sine of phi. When you're given it in component form, that's when it gets hard. Let me just demonstrate what I mean by when you have 3 going in, you have 3 coming out. So let's say my vector is like this. It's in terms of I, J, and K. And I have another one that's like this in terms of I, J, and K. And if I were to curl my fingers of A crossed with B, right, I would get my thumb that would go in a 3D direction. So then we would have our answer in terms of I, J, and K. Okay, now they didn't complete the PowerPoint. So if we want to use this equation, AB sine theta, you could get the magnitude of A, if you're given it in component form, the magnitude of B, and then use your whole arc cosine formula and the dot product to figure out what phi is. But that sure, it takes a long time. So we have another equation in component form. So let's open your book. It's in your book. I should have put it in the PowerPoint, but they didn't. Okay, so on page 23. So on page 22, they started vector product. And they told us on the left on page 22, C is equal to the magnitude of A times the magnitude of B times sine phi. But on page 23 at the bottom, they give you the equation in component form, where you have a Cx, a Cy, and a Cz. Okay, so Cx is AyBz minus AzBy. Cy is AzBx minus AxBz. What does that mean? If you're given two 3D vectors you're crossing, you're going to have 3D in your answer. So AY is the Y component of the first vector, BZ is the Z component of the second vector, minus AZ, the Z component of the first vector, times BY, the Y component of the second vector, like that. Now, if you only have an X and a Y, you only have the CZ, the last term. But if you have an X, Y, and a Z, you have to go through this whole thing. Okay, so it just takes longer. And then you put your answer in terms of I, J, and K. But that's easier than trying to get the magnitude of both using your arc cosine to get the angle. This is easier if you're given it in component form. Okay, so let's do some problems. First, just as a review, it's all crammed in here. I'm going to start with these vectors, A and B, okay? A is vertical, going up. It has a magnitude of 5. B has a magnitude of 10, and it's on an angle of 60 degrees. So I want you just to tell me A plus B. Okay, so you have to get the components of B, 10 cosine 60, 10 sine 60. Then you add the X to the X, you add the Y to the Y. Put your answer in terms of I and J. Okay, so once you get those, you combine the x to the x and the y to the y. So you have 10 cosine 60, 10 sine 60. Then you have your ax and your ay. What's your ax? 0. Okay, your ay is 5. Whenever we add vectors, we have to put them in component form. So I'm just summarizing what we've already done. When you add vectors, you have to put them in component form. You cannot have them in polar form. So we get bx is 5, by is 8.66. We have to add the x to the x, so we have 0 and 5. Okay, so what you get, and I want you to put it in unit vector form in terms of I and j. After that, we're going to do 2a plus 2b. But each time I want you to put it in unit vector form. Then I want you to do the dot product. So you're doing a plus b, 2a plus 2b, and then a dotted with b. So you add the x to the x, you get 5. So that should be 5i. You should put it in terms of I and j. And you add the y to the y, so you get 5 plus 8.66. This gives you 13.66j. Okay, then you're doing 2a plus 2b. Okay, so you're just doubling your a. 2 times 0 is 0. 2 times 5 is 10. You're just doubling everything. And then you're doing a dotted with b, that whole ax bx plus ay by. So our b was 5 and 8.66, so 2b is just 10 and 17.32. Okay, so we had a plus b is 5i plus 13.66j. All right, we just added the x to the x, the y to the y. 2b, we double our b, 10i plus 17.32j. 2a, we double our a. So our x was 0, so twice 0 is 0, and our y is now 10. And then you're adding these together, and you're getting the dot product. Kaylee, do you have 2a plus 2b? Good. So all we do, again, we're add the x to the x. We get 10 plus 0 is 10. 17.32 plus 10 is 27.32. So it's the same thing over and over in adding vectors. We have it in component form. We add the x to the x, the y to the y. Now, you would notice that 2a plus 2b is the same thing as 2 times the quantity a plus b. We could have pulled that 2 out. So back in the beginning, I had 5i plus 13.66j right here, which was c. So 2a plus 2b, you pull the 2 out and you just get 2c. I could have doubled this from the beginning. I didn't have to go through step by step 2a and 2b. I could have just doubled c. Naya, do you have the dot product?
I have 43.3.
Okay, good. So our dot product is ax, which is 0, times bx, which is 5, plus ay, which is 8.66, times by, which is 5 to 43.3. That is a scalar. So this summarizes everything we've done, except for the 3D getting your angle. We'll do one of those later. We started out with 2 vectors. In order to add them, we had to break them up into x and y. So we got a plus b. And then we had 2a plus 2b, where you can double your a and double your b and add them together, or you can pull that 2 out and just double your c. Okay? Are there any questions? All right, so that summarizes the whole getting your components, adding them together. Now, if I have this vector here, 10a, my a is 10, my b is 12. The angle between them, phi, is 40 degrees. I want to know what's the dot product and what's the cross product. I want you to do both cross product and dot product. Okay, so you're going a times b times the cosine of phi and a times b times the sine of phi, but one of them has direction and one doesn't. So we have it right here. A times b times the cosine of phi times b times the sine of phi. Now put in your direction where there is a direction. I made phi simple. Phi is 40 degrees. Phi is the angle between the 2 vectors. Do your right-hand rule to figure out the direction. So we have 10 times 12 times the sine of 40. And we have 10 times 12 times the cosine of 40. Naya, did you get the dot product?
91.93.
Okay, good. It's just 120 times cosine 40. Jaden, did you get the cross product?
77.1.
Okay, what's the direction?
Away.
Okay, so we crossed A with B, good. A with B is like this, so it's into the board. Now, into the board is a negative, so we write that as negative 77.14 K. If it was out of the board, it would be positive K. Okay, so we went A crossed with B into the board. If it had been B crossed with A, it would have been out of the board, positive K. So again, if all we have is an X and Y, our cross product is always in the Z plane. Let's do another one. This time I have vector A is 20 at 55. Vector B is 16 out at 200. And I want to know A crossed with B. Okay, so your phi is the angle between them. So what's phi? Okay, so the angle is going to be 200 minus 55, which is 145. So we get 20 times 16 times the sine of 145. Now you have to put your direction in. Naya, do you have it?
183.54.
In the direction?
Still working.
Kyla, can you tell me the direction? It's either going to be into the board or out of the board. Point your fingers in the direction of A with your right hand. Curl them towards B. Which way does your thumb go? Into the board or out of the board? Out of the board. So how do we write that? Jaden, how do we write out of the board? Positive K. So we get 183.5 K. All right? Now, I want you to use the equation on page 23. So let's open your book if you have it on 23. Now, we only have an X and a Y, so we're only using CZ. So CZ is AXBY minus AYBX. AXBY minus AYBX. Okay, because we only have that Z component. So you're going to have to get your components using cosine and sine. 20 times the cosine of 55, 20 times the sine of 55. And the same thing here. And then you're going to plug it in and you're going to get it this way. And you should come out to the same answer. So we're using our other definition of cross product. This is just the math behind the physics, right? We're not doing any physics yet. As in physics 1, we started with the math behind the physics. We use vectors all the time. Twenty cosine 55 is your AX. 20 sine 55 is your AY. What's the angle you use for B? What? Well, that would be fourth quadrant. This is in the third. So what angle should we use? You could use positive 20 and put the negatives in.
Yeah.
But what angle should we use so the calculator puts the negatives in? 200. Okay, so 16 cosine 200, 16 sine 200, your calculator will put the negatives in. If you want to use 20, you put the negatives in. You could use negative 20, but then you'd have to understand that you have one negative, one positive there. You're plugging it into the equation ax by minus ay bx. Should have gotten this for your value. So both of our b's are negative. If you use 20, that's fine, but you have to put two negatives in. 20 is your reference angle, and 200 is the exact angle. Now, how are we going to know the direction using this technique? We can't really do the right-hand rule very well. You could if you think about those vectors and you draw them out, but without doing all that, how are we going to know the direction? Did you get your answer? Is it the same or similar? We rounded. Right, you can tell by the sign. So AXBY minus AYBX is 11.5 times minus 5.47 minus 16.4 times negative 15.04. If it comes out positive, then that is out of the border, out of the page. If it comes out negative, then it's in 2. Now, remember to put your K in, symbolizing that this is a vector, not a scalar. So it comes out to approximately 183.5 K. So these are our 2 ways of doing it. Now, obviously, the other way was a lot easier, but if you're given it in component form, then this way is easier. So, for example, if A had been force and B had been the lever arm, this would be our torque, where positive K is counterclockwise. Now, it gets cumbersome when you have 2 3D vectors, right? We only had 2 2D vectors, so we just used the third one. But when you have 2 3D vectors, you have to use all of them. So we're going to do one where we have 2 3D vectors, and you have to do the CX, the CY, and the CZ. Okay, but I'm giving you all the components. So let's say we have A and we have B. A is 2I plus 6J minus 3K. B is negative 3I plus 5J plus 2K. And I want to know A crossed with B. Now, the first one is your X, the second one is your Y, the third one is your Z. So you have to plug them all into this equation at the bottom of page 23. So you're going through each one. When you're done, you don't add them together as we did for dot product. You put them in terms of I, J, and K. So for the first one, AYBZ minus AZBY. That's going to be 6 times 2 minus negative 3 times 5. And you do the second one, and you do the third one, and then you put your answer C. C should have an I, a J, and a K. Jaden, did you get the CX? I have 27. Should be 6 times 2 minus negative 3 times 5. So you get 12 plus 15. Okay, we had our AY is 6, our BZ is 2, minus AZ, which is 2, times BY, which was 5. Our AZ was negative 3. Okay, so we get 27. Kelly, what'd you get first? CY. Okay, good. So for CY, we have AZBX, which is negative 3 times negative 3, minus AXBZ, which is 2 times 2. Okay, so we get 9 minus 4, which is 5. Naya, do you have CZ?
28.
Okay, good. CZ, we have 2 times 5 minus 6 times negative 3. So we get 10 plus 18, which is 28. So what is our answer? This isn't really our answer. Jaden, do you have the answer?
27I plus 5J plus 28K.
Good. That's how we write this, okay? So it was just a matter of plugging them all in, getting it straight, which is your X, your Y, your K. So let's do another one. 3I plus 1/2 J plus 10K. Negative 5I plus 3J minus 12K. So it's the same idea. So you have your AX, your AY, your AZ, your BX, your BY, your BZ. Once you get C, I want you to tell me the magnitude of C. So for CX, you should have gone 1/2 times -12 minus 10 times 3, like that. Naya, did you get the CX?
-36.
Good. Jaden, did you get CY?
-86.
Good. So you have 10 times -5 minus -3 times -12. Kaylee, do you have CZ? Good. So our answer is 36I minus 86J minus 6.5K. And you had to get your magnitude. Okay, so just going 36 squared plus 86 squared plus 6.5 squared. Naya, do you have it? You know it has to be bigger than any number going in, so it has to be bigger than 86.
93.46.
Good. Okay, now that would be a negative K. It would have, when we talk about magnitude, we just talk about the absolute value. Okay, now let's do another one. I have A is 15. It's 160 degrees out. B is 3, and it's 300 degrees. So I want to know what is the cross product here. So you're going the magnitude of A times the magnitude of B times the sine of phi. Just figure out what phi is. I drew phi in the picture for you. So A goes to 160, B goes to 300. You can figure out what phi is. So phi is the shortest distance between the two vectors, not the longest distance. So you shouldn't have a phi of greater than 180 degrees. You should have a phi less than that. What's phi? Anybody? What's phi? 140. It's 300 minus 160. The distance from A to B coming in this way. So you have some homework problems where you have to do the vector cross product, and you should look for the shortest distance between them. Okay, so 300 minus 160 gives you 140. So we have, that is our phi. So we're just going A times B times the sine of phi. So we have 15 times 3 times the sine of phi. Naya, do you have it?
Negative 34.47.
Yeah, I have something.
Oh, I used 3 for the negative.
Yeah, I used, I don't know why I have a 4. I have a 4 and a 3. I don't know where that 3, I think that 3 was the original 300. And that was supposed to be a 4. But 3 is fine. That's what I said. So that's what it would be. What'd you say it was, Naya? 100.
34.47.
Yeah, so it only made a small difference. Okay. Now, we can go through and get our parts and do it the other way, right? I think that you understand that. So if we went through and did the cosine and we got the cosine and plugged it in as we did before, we would have had to get the x and the y of each one. So I'm not having you do this because I think we've done it enough. But you would have to go through and get 15 times the cosine of 160, 15 times the sine of 160, and all of that. Okay, now let's do another one where you're getting the angle. So yesterday we went through all of this. We had our first definition of dot product was all of this. Our second definition of dot product was this. So what we did, so this is just the dot product. So this is meant to have a big dot, whereas this is different. This is just the magnitude of A times the magnitude of B. So we avoid using the X to separate this from cross product, which uses an X. We divided down both sides by AB, so I canceled this. So we got cosine phi is equal to AX BX plus AY BY plus AZ BZ over the magnitude of A times the magnitude of B. Okay, so this is how we get the cosine between two 3D angles, and you can do it between two 2D angles. You have to use arc cosine in the end. Okay, so this is our arc cosine is our phi. So I'm going to give you two 3D angles, and you're doing the same thing. Okay, this is your A, and this is your B. We're going to use our two definitions of cross product to get the phi. Show me if you have it. So you're plugging it in, your whole AX, BX plus AY, BY plus AZ, BC. Then you're getting the magnitude using the Pythagorean theorem. Do you have it, Naya?
51.4.
Mm. So your whole dot product in the top, 3 times minus 2 plus 6 times 4 plus minus 2 times minus 1 comes out to 20. Your magnitude of this one came out to 7. Your magnitude of that one was square root 21. You have to do arc cosine this entire thing, 20 divided by 7 times radical 21. Comes out to 51.4 degrees. Okay, so this is the angle between two 3D vectors. Okay. So if I want to get the cross product of these vectors, okay, tell me the cross product of them. You have everything you need to get the cross product. It shouldn't be much work. Show me if you have your vector cross product. What I had hoped you would do is not do much work, but just use the definition, the magnitude of A times the magnitude of B, which you already have, times the sine of phi, which you just got. So you just got the magnitude of A was 7, the magnitude of B was radical 21, and so you multiply that times the sine of 51.4, and you get 25.1 quite quickly. Okay? All right. So far for homework, we're just doing 143, 144, 146, 147, 148. So 1.43, 44, 46, all the ones we haven't done. Now, they hardly have you use that equation on the bottom of page 23. They mainly have you use the other one. All right, we're going to go on break.